All right, let's talk about how money is created. The banking system in the United States today is called a fractional reserve banking system. And they call it a fractional reserve because whenever the bank accepts deposits, they only keep a fraction of those deposits on hand and then they can loan out the rest. And this began with the goldsmiths. So the goldsmiths stored gold for people and then they gave a receipt. And the receipt was used as money by the public. So that way they weren't always carrying gold with them. And then eventually one goldsmith figured out and made the astute observation of that no one really ever came to him and withdrew the whole amount of gold that they stored with him. In fact, he found that people were depositing more gold with him than they were withdrawing. And so he had the idea that he could actually make a loan to the public that was greater than the amount of gold he had in the vault. If people never came and reclaimed the full amount of their gold, then, they would be none the wiser. And since he lent out money that was greater than the total amount of gold in the vault, money was created that way. So if there was $10,000 worth of gold in the vault, but he gave receipts total of $15,000, then $5,000 of money was created. And that is how the fractional reserve banking system began. Of course, it's evolved to a much more complex system today, but that is the origin. So oftentimes, people think that money is created by, they get the image of the printing press, of the treasury printing bills, but 95% of money is created through lending. The weakness of a fractional reserve banking system is that they are vulnerable to panics. If everyone was to go to the bank at the same time to withdraw their money, the bank wouldn't be able to give everyone their money because, as we said, they only keep a fraction of that money in reserves and they lend out the rest. So in the stock market crash of 1929, there was a huge run for the bank. The banks couldn't give everyone their money. The banks closed for a few days and eventually the public realized they weren't getting their money back, and hence the Great Depression. In fact, FDIC, Federal Deposit Insurance Corporation, was created, and at the time, they said they would insure $100,000 of money per bank. So each person per bank got $100,000 of their money insured, and this was created to prevent another run of the bank, because at the time of the stock market crash of 1929, that didn't exist. In the Great Recession of 2007, the same fear arose, and since U.S. wealth has risen considerably, the government increased that amount to $250,000 because they were worried about another run on the banks, and so many financial institutions were failing or were on the brink of collapse. Okay, so to understand how a fractional reserve banking system creates money, we're going to start with the basics here. So each bank has a balance sheet and it has assets, and assets will equal liabilities plus net worth. Assets are what the bank owns, liabilities are what the bank owes, and net worth is assets minus liabilities. Okay, and both sides of the balance sheet have to balance. Okay, so if someone deposits $100, then it's an asset to the bank because right now they are temporarily owning it, but it's also a liability because they owe that money to that person who deposited. And so in order for money to be created, a bank has to be created. They have to accept deposits, and then they have to lend out their excess reserves. Excess reserves are what are left over once the bank holds their required reserves. Okay, so some citizens in the town of Wahoo, Nebraska decide that they need a commercial bank. And so, they secure a national charter for the bank, and then they sell about $250,000 worth of stock to buyers. It could be in their community or outside their community. And so the original balance sheet for this bank is, okay, the stock shares that they sold is a liability, $250,000, because they owe that to the holders of the stock. But it's also an asset because now the banks have $250,000 worth of cash. Okay, so now Wahoo Bank needs to acquire property and equipment. And so they spent $240,000 of the $250,000 on acquiring this. And so the composition of the assets change. So they own $10,000 cash, $240,000 in property. But notice the liabilities is still the same. They still owe $250,000 in stock shares to the public. Now the bank is truly ready for business, and they accept $100,000 in checkable deposits. So now they have $110,000 in cash, and again, they owe $250,000 to the shareholders and $240,000 they own in property and equipment. Okay, so each bank is required to keep a fraction of their deposits in reserves, so they can keep the reserves in their local Federal Reserve Bank, or they can keep it in their vault, and usually banks do a combination of the two. So if the reserve ratio, for example, is 10%, then if $100,000 is deposited, then they have to keep a minimum of $10,000 as required reserves. Can they keep more? Yes. Can they keep less? No. Okay, so the reserve ratio is the commercial bank's required reserves divided by commercial bank's checkable deposit liability. So if the reserve ratio is 0.1, then the bank has to keep 10% of deposits as reserve. If it's 0.2, then they have to keep 20% of deposits as reserves, and etc. Okay, so the Fed establishes the reserve ratio within the limits set by Congress. They can vary it. They rarely vary it. It can be disruptive to the banking system. But they have it, the first 0 to 12.4 million does not have any reserve requirements. The 12.4 to 79.5 million, the requirement is 3% of those deposits be kept in. And then over 79.5 million, then the bank has to hold 10% of those deposits on reserve, though the actual amount can be varied between 8 to 14%. Okay, in this scenario, the bank deposits all its cash on reserve at the Fed. It's expecting more deposits to come in, so they go ahead and deposit a large chunk to have on reserve at the Fed. And therefore, their balance sheet for assets is 0 cash, reserves is $110,000, property $240,000, and then stock shares again $250,000, and checkable deposits $100,000. Also, just to note, reserves here include excess reserves and required reserves. Okay, so excess reserves are actual reserves minus required reserves. And so required reserves is the reserve ratio multiplied by checkable deposits. And so in this example, the checkable deposits is $100,000, and let's assume the reserve ratio is 20%. So required reserves would be $100,000 times 20%, so this would be $20,000. The reserves that was deposited with the Fed was $110,000 minus the $20,000 that was required from this amount, and so excess reserves are $90,000. So really, the bank just needs to hold on to $20,000, and then the rest is considered extra reserves. Let's look at a scenario. A customer has money in Wahoo Bank, and he writes a check to purchase equipment Okay, so let's say he writes a $50,000 check, and so now checkable deposits go down to $50,000. Remember, they were $100,000, and someone wrote a $50,000 check, so now they're down to $50,000, and also reserves fall to $60,000. Okay, so 20% of the required reserves for checkable deposits, so 50,000 times 0.2 is 10,000. So out of the reserves here in assets, okay, 10,000 is required reserves, and then the other 50,000 are excess reserves. Okay, so let's say a company wants a $50,000 loan in order to expand its operations. So what happens is once Wahoo Bank determine that this company is creditworthy, they will increase the company's balance on their account with Wahoo by $50,000. So checkable deposits go up by $50,000, so it's total of $100,000. And also, a loan was created here in the asset category of $50,000. Okay. If you look at the previous slide, checkable deposits were $50,000, and there was no loan category. And now we can see here, okay, that the liabilities column increased by $50,000 and the assets column increased by $50,000. In essence, money was created. Okay. The bank just created money. So the company went to the bank and walked out with money. And then the company would not only eventually pay the loan back, but it would also pay it back with interest. Okay, so once the company actually cashes the check, checkable deposits fall by 50,000, and then reserves fall back to 10,000. Okay. But we can still see the loan category here of 50,000. Now, if another customer were to come in and want a loan, the bank right now would have to say no because it already loaned up its excess reserves. They cannot make loans on its required reserves. Okay, so this point right here down. Okay, we need a circle, star, highlight, smiley face, whatever. Okay, make sure you remember, but a bank can only lend an amount equal to its pre-loan excess reserves. Loans come from excess reserves. So the bank happened to have $50,000 in excess reserves, and they loan that money to the company. And so until they get more checkable deposits, they can't they can't make any further loans. And the process works in the reverse. When the loan is paid back, then the amount of the checkable deposit decreases. And so money is destroyed. So money is created when loans are made, and money is destroyed when loans are paid back. Okay, so let's go back to the balance sheet that we were looking at in transaction 5. And so let's say in this case, the bank buys government securities from a dealer. Securities are stocks, bonds, and other financial assets. So securities appears here as an asset. Let's say it's $50,000 worth. Checkable deposits also go up to 100,000. Okay. So again, we see that the money supply has increased. Now, when the security dealers draws a check for $50,000 against Wahoo Bank, then it loses the bank loses its reserves and deposits in that amount, and then securities becomes loans on the asset side. So a bank does have two conflicting goals. They want to earn a profit, and one way they earn profit is by making loans and earning the interest, and also buying securities to earn interest. But when they do that, it draws against their reserves, and the less reserves they have, then the less liquid they are, and they want to make sure that they're liquid in case people start withdrawing more money than they're putting in. If this were the case and the bank dropped below their required reserves, they can take an overnight bank loan from the Federal Reserve Bank, and the Federal Reserve Bank will charge the commercial bank an interest rate for that loan. It's called the federal funds rate, and this is what open market operations targets. We'll talk about this more in the next chapter. All right, let's look at an example of how much money one deposit can create. Okay, so we're going to assume that the required reserve is 20%. The banks are loaned up, meaning that they have lent all of their excess reserves, and they can't lend out any more money or create any more money unless there's a new deposit. So let's say someone finds a $100 bill and deposit it in the bank, and once that bill is deposited, then more money can be created. Okay, so Bank A is the bank that received the $100 bill. Okay, their required reserve is $20. Their excess reserve is $80. So they lend out $80 to a customer. Customer B goes to Bank B and deposits their money. Okay, so the required reserve of $80 is $16. The excess reserve is $64, so they lend out $64 to customer C. So customer C takes that $64 loan, deposits it in their bank. Okay, and so Bank C now has $64 in deposits. They're required to keep $12.80. $51.20 are in excess reserve, so they can loan that out to customer D. Customer D deposits that in their Bank D. Again, required reserve is $10.24. Excess reserve is $40.96. Okay, as long as the loans and the money are deposited at a bank at each stage, then the process will continue, okay, until what we see, okay, is that from the original $100 that was deposited over here, okay, through the banking system, assuming again that money was deposited at each stage, $400 of new money was created. Okay, now let's say the process stopped at Bank D, okay, then only $40.96 was created. Okay, but if, as long as customers keep depositing their money in a bank along the way, then $400 can be created. Okay, and so we don't have to sit here and do all this tedious math. There's a shortcut, and this is called the money multiplier. And this is 1 divided by the required reserve ratio. So in this past example, it was 1 divided by 0.2. Okay, and we get 5. Right. So our initial deposit was $100 times 5. Okay, we get 500. Okay, and once we subtract the initial deposit, we can get that $400. Okay, can be the maximum created from the deposit of $100. Now, if the reserve was lower, let's say it was 0.1, then the money creation potential is even higher. So if it was, let's say, 0.1, okay, the money multiplier would be 10. So the initial $100 would create a potential $900. As long as money is deposited each stage, then the initial $100, if the reserve ratio was 0.1, could create an additional $900. Okay. And this is how money is created through the banking system. It is created through the lending of excess reserves. Okay, and so we saw that the higher the reserve ratio, the lower the multiplier is. The lower the multiplier is, then the less money that can be created from a single deposit. And the reverse is true. Okay, the lower the reserve ratio is, then the higher the multiplier is, and the more money that can be created from a deposit. And so making loans creates money, but also when loans are repaid, it destroys money. Okay, so this concludes chapter 33, money creation.